All right, so we're continuing looking at rational functions. We're going to focus specifically today on getting graphs done. Yesterday when we graphed, we had two basic shapes. We had the kind where we had a branch up here, right, and one here. And then we had the other kind where they were both on the top, right? And then we shifted them left, right, up, down. We did some of those basic ones. Today we're going to look at graphs that are different shapes. Okay, they're still rational functions, but they're not going to have that same pattern to them. The steps that we need to go through. We have to find any asymptotes. Vertical asymptotes, horizontal asymptotes, slant asymptotes. Any asymptotes, we're going to figure out what those are, get them graphed. Okay. Then we're going to look, are there any holes that we have to worry about? Then we're going to look at finding x and y intercepts. And last, we're going to fill in a few more points to get our picture drawn. Okay. You will start to kind of get familiar with the different types of shapes and maybe be able to predict a little bit more with just a couple points graphed. So that's kind of where we're headed. Okay, so for our first example, is there anything that needs to be factored? Can I factor the numerator or denominator at all? No. Okay, so looking at it the way it is, vertical asymptotes, we said look at the denominator, right? What makes the denominator equal to 0? So what would make this one 0? So we have a vertical asymptote at x equals 1. Do we have any holes? Not on this one. Okay. Then we look at horizontal asymptotes. That's the one where we focus on the degree. What do we know about the degree? So both of them have a degree of 1, which tells me I have to look then to their leading coefficients. Okay. In this case, my leading coefficient is a 2 over a 1. So y equals 2 over 1, or just y equals 2. All right, let's go ahead and graph that. We have a vertical one at x equals 1. And we have a horizontal at y equals 2. Okay. Next step is to figure out if there's any intercepts. Remember, for x and y intercepts, we're just putting zeros in one at a time. So my x-intercept is what I get when I put a 0 for y. My y-intercept is what I get when I put a 0 for x. Okay, so putting a 0 for y, that means I'm going to change f of x here to a 0. And I want you to think of this as if it were a proportion. Plus 2. If it was a proportion, we could cross multiply. And we would have 0 times 1 times x minus 1 equaling 1 times 2x minus 1. Yes? But 0 times anything is 0. So when you have a rational function and you're putting a 0 in the y position, it really doesn't matter what the denominator is. Because when you cross multiply, it's going to still become a 0. So we really just have to focus on what makes the numerator give us that 0. Okay? So x-intercepts, you're going to focus on numerator. What makes this 0? So we're going to add the 1 to the other side and divide by 2. Okay? Now, if I put 0 in for my x's, the 2x disappears, the x on the bottom disappears. All I have left would be this piece. Yes? And negative 1 divided by negative 1 is 1. Okay, so let's plot our intercepts. We have 1 at 1/2, 0, and we have 1 at 0, 1. Okay? When you are graphing rational functions, we are going to have to fill in a few more details here, right? We need more dots than what I have right there. I can't tell the picture yet. So we're going to fill in a few more things. I have a few dots to the left of my vertical asymptote. Let's get a few dots to the right and see what's happening on that side. Okay, so I'm going to put in a 2 and a 3 and see what I get. All right, so putting a 2 into my equation for x. 2 times 2 is 4 minus 1. I get 3 on top. Putting a 2 down here, 2 minus 1 is 1, so I get a 3. Okay, so the point 2, 3 is on my graph. If I put 3 in there for my x, 2 times 3 is 6, minus 1 is 5, 3 minus 1 is 2. 5 halves are 2.5. So over 3 up 2.5. Okay? Now, if you think about the pictures we had yesterday, could we make an assumption that we have a branch here and one here? Okay, based on the dots I have, that seems reasonable. Okay. But keep in mind, they won't always be that shape. All right, let's try another one. Is there anything I need to factor? Yes, the x squared minus 9 becomes okay. Are any of the factors going to drop out? All right, so I don't have any holes. Do I have any vertical asymptotes? Are there points of discontinuity, things in the denominator that are going to cause problems? Yes. Where are they? At x being positive and negative 3? Okay, so go ahead and put those in as our vertical asymptotes. Okay. Then let's move on to horizontal asymptotes. What's the degree in the numerator? The degree on top. Do you have an x on top? No, so degree is 0. Degree on the bottom is 2. So what's our rule? If the top degree is smaller, we have one at 0. Okay, so we've got all the different asymptotes drawn in. Then we start looking at plotting some points. We're going to first find our x and y intercepts. All right, if we put a 0 in for y, remember, we're looking at what makes this 0. Denominator is not going to matter because when we cross multiply, 0 times x squared minus 9 is still 0. We end up with 0 equaling 2. Can we have that? Can 0 equal 2? Okay, so we're going to say there's none. Okay, there's no value for x that would make the top 0. Okay, it's just a constant 2. But if I put a 0 in for x, now I end up with 2 over negative 9. So negative 2/9 is going to be my y-intercept. All right, so let's go ahead and fill that in. Not quite negative 1/3. 3/9 would be 1/3. Okay, but that doesn't help me a whole lot because my vertical asymptotes have split my grid into 3 sections. And then I have a horizontal one, so I have kind of 6 different chunks on this grid that I have to figure out where are my graphs going to show up. Okay, I have one dot in the middle here, so I know that there's going to be something down in this section. Okay, but there's more stuff that's happening. All right, that's why those vertical asymptotes are there. There's got to be something going on outside of that section. So we need to fill in a few more details. And for this particular one, we're going to fill in quite a few. As we get more familiar with what these might look like, we won't have to have quite as many points. So we're going to put in, let's see, negative 5 and negative 4 to get something on the left side of my graph. I'm going to fill in a little more details in the middle section here I only have that one red dot, so let's put in a -2 and a +2. And then we need something on the right chunk. So let's put in a 4 and a 5. Now, my question for you is, if I put in a +4 and I put in a -4, will I get different answers? Look at your equation. If I put a +4 or a -4 in, will I get a different answer out? No, because I'm going to square my x, right? So if I put in a 4 or a -4 and square it, it becomes 16. 16 minus 9 is 7. I end up with 2/7 for my 4s. Okay. If I put 5 and -5 in, I'm going to get the same answer out, yes? Putting those in gets me a 25 minus 9. 25 minus 9 is 16. 2 divided by 16 is 1/8. Okay? And then putting a 2 or a -2 in. When I square it, it becomes a 4. 4 minus 9 is -5. 2 divided by -5 is -2/5. Okay? Now, you can put those down as decimals if it makes it easier for you to figure out where to graph them. A 1/8 is the same as 0.125. 2/7 I think was like 0.29. 2/5, this would be -0.4. Okay, so let's go ahead and plot those points. So at -5, I'm only up an 1/8. Okay, and at +5, I'm up an 1/8. -4 and +4, I'm up almost to a third, not quite. And then 2s and -2s, I'm down about -0.4. Okay, so it's filled it in a little bit more for me. And knowing that the asymptotes are lines that my graph should be approaching, I can make a prediction that I'm going to have one branch over here. Okay. In between, my middle dot's a little higher than the other two, but not drastically. It's pretty flat in there. All right, but it has to approach those vertical asymptotes. So I'm looking at something kind of like a parabola, only a little flatter on the top. It's not totally flat, but pretty close. And then on the right side, I'm expecting a branch like that. Okay. Now, keep in mind that we were told we had a function, right? We were told f of x, and we've talked about it before, right? Functions have to pass what kind of test? A vertical line test. Does this pass a vertical line test? Yes. Always be looking at your final graph and seeing if that's the case. All right, these should all be functions. They should pass a vertical line test, which means if I have a grid or part of my graph up in this chunk, right, I'm not going to have anything down here. Does that make sense? Because it wouldn't pass a vertical line test if I did. Okay? All right. Looking at our last problem on this page, is there anything that can be factored? The bottom, what would it factor into? Okay. Are any of my factors going to drop out? Okay, so no holes. I will have some vertical asymptotes though. I've got 2 points of discontinuity in the denominator. One at +4 and one at -2. Okay, let's go ahead and graph those. Looking at degrees, talk at your tables. What would our degrees tell us about a horizontal asymptote? Okay, I'm hearing top is smaller. Agree? So horizontal asymptote is at y equals 0. All right. Finding our intercepts. All right, if we put a 0 in for y, we're looking at what makes the top 0. What would make the top 0? A 3? All right, so I have an x-intercept at 3, 0. Okay, and putting a 0 in for x, what happens? The top becomes -3, the bottom becomes -8. -3 divided by -8 would be positive 3/8, so not quite a half. Okay. Now, just looking at that middle section, on the left part, I'm above the x-axis, and then over here at 3, I hit the x-axis. So my prediction is that I'm going to have to be up on top over here on the left part of it and down below here. I have to cross the x-axis at 3. All right, but we can fill in a few more points to help us out. But I still need to find stuff on the far left and far right. So let's use -3 and -4 on the far left. And let's fill in, let's do -1. And let's do 5 and 6. Okay? So I'm going to pause the recording. We're going to split it up. Each of you will do a number. So front two tables here, -3. Back table, -4. Up here, -1. 5, 6. Okay? Go ahead and figure out what your value is. All right, let's complete our table. Those of you who had -3, what did you get? -1? Agree, disagree? I'm hearing some questions in your answer here. You're not sure. If we put in a negative, what did we have? -3? Put a -3 on top, we get -6 on the bottom. You can either plug it into the original or into the factored form, whatever's easier. If I put it in the factored form, a -3 here makes this -7, and a -3 makes this -1, which makes the denominator +7. So I end up with -6/7. Yes? Okay, so close to -1, not quite. So at -3, we're at -6/7. Okay? If I put a -4 in, on the top, -4 minus 3 gets me a -7 on top. -4 on the bottom here makes this -8. And a -4 plus 2 makes it -2, which gets me a 16 in the denominator. -7/16. So almost to -1/2. Okay. So in that side of my graph, I'm making a prediction. I've got this kind of thing going on. Okay, knowing it has to approach those asymptotes. All right, those of you who put a -1 in, what did you get? Agree, 4/5? Okay. So at -1, we're up at 0.8. So thinking about the fact that I have to be positive over here, and I have to hit 0 here, I'm looking at it crossing, coming down very gradually and crossing and going low. Okay. How about 5? What did we get for 5? Agree? Anybody else get that? Yes? Okay. And 6?
3/16.
Okay. So 2/7 for 5. and 3/16 for 6. So we're looking at a branch coming down here. Okay. Is it a function? Does it still pass a vertical line test? Yes? Okay. All right. We are going to move on to a couple where we have a slant asymptote. We've talked a little bit about slant asymptotes already. We said it shows up if the degree in the numerator is exactly one more than the denominator. Okay? But we're actually going to find them today, not just say there's one out there. We're going to figure out what it is. And we can do that using division. We're going to take our rational function, which, because it's a fraction, means we're dividing, and we're actually going to divide it out. We can do this either with long division or synthetic division. Long division is a little putzier, so if we can get by using synthetic, we will. All right, I'm going to just pause this for a second while you copy that down. All right, so we're going to go through the same routine that we've been doing with the addition of the slant asymptote idea. Is there anything that can be factored? Can we factor x squared plus 1? Not with real numbers. We can use imaginaries, but that's not going to help us with our graph. So, nothing to factor. So, go through our list. Vertical asymptote. Is there anything in the denominator that can't disappear? What makes the denominator 0? Okay. All right. Then we look at horizontal asymptotes. Focusing on degrees. Now the top degree is bigger, right? Top degree bigger means what? Okay. If the top degree is bigger and there's no horizontal asymptote, we go to our next step. Is there a slant asymptote? For that, we have to look at the degrees. Is the top degree exactly one bigger than the bottom degree? Okay, so we are going to have a slant asymptote. We find it using division. So let's go ahead. Can we do this synthetically? If our divisor here is an x minus 1. Yes. Okay, so we're going to do synthetic process. What goes in front if we're dividing by x minus 1? Positive 1. Do we have any terms that are missing where I need to fill in a 0? Look again. X squared plus 1. I'm missing what? The x's. So for x squareds, I have 1 as a coefficient. For the x's, I don't have any, and my constant is a 1. Okay? Synthetic process, as we bring down the 1, our first term here, multiply these. 1 times 1 is 1, and add. 1 times 1 is 1, and add. The last number is always what? Okay, so if I were going to write this out, that would be the remainder. This would be the constant, right? And this would be my x. So it would be x plus 1 plus 2 being divided by x minus 1. Now, asymptotes are lines that your graph approaches as you move away from the origin, right? As you go towards negative or positive infinity for x. What happens to this remainder as x gets really, really huge? If x is at infinity, infinity minus 1 is still a pretty big number, right? Okay? And 2 divided by a really big number is really small. So as x gets bigger and bigger and bigger, this 2 over x minus 1 becomes almost nothing. So when we talk about our asymptote, the remainder is not going to affect it. It's going to basically turn into a 0 as x gets big enough. Okay? So we ignore the remainder part and we take the other piece. So y equaling this x plus 1, that's my slant asymptote. Okay? So drop the remainder off. Doesn't matter what it is. It's going to end up becoming very close to 0 as x gets huge. and we take the other piece. So how do we graph the line y equals x plus 1? Right? Think mx plus b. It's just a line. Y-intercept is the 1. Slope is a 1. Right? So let's go and draw a line in. We have a y-intercept of 1 and a slope of 1. All right, so I've got a slanted line that my graph is going to be approaching. Okay? We found all of the asymptotes. Now let's go and see if we have any intercepts. All right, any x-intercepts. If I put 0 in for y, is there anything that will make this top 0, the numerator 0? When I take x and square it, whether x is positive or negative, when I square it, it becomes positive, right? And adding 1 is going to just make it more positive. Even if I put a 0 in, the numerator would still be a 1, right? So there's nothing that's going to turn the numerator into 0. So for my x-intercepts, I'm going to say there's none. Okay. What do I get for y-intercepts? If I put a 0 in for my x's, this becomes 0, this becomes 0, and I end up with that, right? 1 over negative 1 is negative 1. So I know that I'm not going to hit the x-axis at all, but I am going to hit the y-axis at negative 1. Okay? So we need to fill in a few more points here. Let's take, let's do negative 1 and negative 2 to get something to the left of my y-axis here, and then something to the right of my vertical asymptote, maybe a 2 and a 3. All right, so front tables here, put in a negative 1, back tables over there, negative 2, positive 2, negative, or positive 3 for you guys. All right, if we put in a negative 1, we got negative 1. If we put a negative 2 in, what did we get? What'd you get?
I got it wrong.
Not necessarily.
I got 5.
Okay, negative 2 squared becomes 4. We get 5 on top. Negative 2 minus 1 becomes negative 3 on the bottom. So 5 over negative 3, negative 5/3. Okay, putting a positive 2 in gets me positive 2. 2 squared is 4 plus 1 is 5 on top. 2 minus 1 is 1. 5 over 1 is 5. Put a 3 in. 3 squared is 3 squared. 9 plus 1. 10 on the bottom. 3 minus 1. 10 over 2. All right. So plotting those points. Over 2 up 5. Over 3 up 5. Negative 2, we're at negative 1 and 2/3. At negative 1, we're at negative 1. Okay? Now, when you have a slant asymptote, there's 2 basic pictures you can expect to see. One of the pictures has the dots like we have here, where they're in between the vertical and slant asymptote. Okay? My graph is going to look something like this. Now, notice that we had 2 5s here. It's not flat there. It does go below and then back through the other 5. Same thing here. It's going to go up above that negative 1 and then back down through it. Okay? That is a very typical shaped graph when you have a slant asymptote. The other option is that you're going to have curves on the outside of the asymptotes. Okay. All right, we got one more to try. Can we factor it? All right, let's try factoring the top, see if anything's going to cancel out for us. 2x squared, we'd have to break into 2x and x. Okay. To get a 5, we need 1 and 5, or negative 1 and negative 5. Where am I going to put them to get a negative 7? Anybody? Okay, like that. Does that work? Any factor is going to cancel out. No, so we're not going to have any holes again on this one. So let's go through our list. Vertical asymptotes, anything that makes the bottom 0, the denominator 0. A 2, so x equals 2. It's going to be a vertical one. Okay, horizontals. Look at your degrees. Top degree is a 2, bottom degree is 1. Top degree bigger means what? None. Is there going to be a slant asymptote? Is your top degree 1 bigger than your bottom degree? Yes. All right, let's go ahead and find it. Can we do this synthetically? Okay. What's going to go in front? A 2. And then are we missing any terms? Do we need any zeros? No. So 2, negative 7, and 5. We bring down our first 2, we multiply them, and add, multiply, and add. Do we care about the negative 1 on the end? No. We drop off that remainder. We only worry about the other numbers. What is this equation going to be? 2x minus 3. Okay. So to graph that, we would have to start at negative 3 for my y-intercept and do a slope of 2 up 2 over 1. Okay, so there's my slanted line that I'm going to be approaching. All right, finding our intercepts. If I put 0 in for y, we're basically saying what makes the top 0. Well, I've got factored form. What makes this 0? My first factor is 0 if x is right here. What's x have to be? Work it out, guys. When does it give me a 0? Add your 5 and divide, right? So 5 halves. But I have another one. When does this one going to make a 0? At 1. So I'm going to have 2 x-intercepts on this one. All right, so one at 1 and one at 2.5. All right. How about y-intercepts? If I put a 0 in for all my x's, this is gone, this is gone, this is gone. I end up with that. So negative 2.5. Okay. Let's do one more point. Let's do 4. What do we get if we put a 4 in there? I usually use the factored version. All right, so if I put 4's in here, 2 times 4 is 8, minus 5 is 3. 4 minus 1 is 3. And on the bottom, 4 minus 2 is 2. So I end up with 9 halves, or 4.5. Okay, so this is the other type of graph I said you're going to see, where you have branches that are outside of the asymptotes. It's going to come down here and approach that. And then same thing here. It's going to come down along there and kind of go off slanted there. Okay. All right. your assignment. You have 12 of them to do. You should have been given a piece of graph paper. If I missed your table, let me know.